To continue our discussion of histograms, we'll construct a histogram from the frequency distribution data that we used previously. This is the data of the 50 test scores on the statistics exam, and recall that we put that in a table where we had our classes and we counted how many, the frequency in each one of our classes after we constructed the classes, and then from that we computed a relative frequency. What percent of the scores fell into the first class, the second class, and so on. So now we'll use the data in the frequency column to construct a histogram, and then we'll use the data in the relative frequency column to construct a relative frequency histogram. Okay, so we'll use this grid for our calculations and for our histogram. So recall that we said our horizontal axis here was the quantitative values. These are our test scores. Those are numbers that represent counts or measurements. We will have 7 vertical bars because we have 7 classes. So let's see where they'd be. Let's see, one here approximately. They're about the same width. 3, 4, 5, 6, 7. And this is where we'll start. And recall that we said to keep our histogram less cluttered, we wouldn't want to use these lower class limit, upper class limit to label with. We want to use the midpoint. And we had calculated that before, but just as a reminder, let's look at how we would do that. Remember, the midpoint of the first class was determined by taking the average of the lower class limit and the upper class limit. And we got 14.5, so that's the representative value for this class. And then we said that we could continue calculating those, but there's a pattern there, and we don't really have to do that. We know the class width is 10, so we could just add 10 to the midpoints and get that representative value for each one of these classes. So I'll just jot those down right here. 64.5 and finally 74.5. So that's the value that represents each of those classes. So now I can label my horizontal axis. This first bar will represent the 14.5 class, and then 24.5, 34.5, 44.5, 54.5, 64.5, and finally 74.5. So these are the test scores. Okay. So now we want to draw our histogram using the frequency data. So I need to set my scale over here. Let's see. We'll use this color. Okay. So for my scale here, I would use, let's let this first mark be 5, a frequency of 5, 10, 15, 20. So these are my frequencies. So the height of the bar is going to give me the frequency. So in the first class, the height is, the frequency was 2, so the height of the bar should be right at about 2. The next class was 4. The next class, 7. And in the next class, 44.5, we had 10. In the next class, we jumped from 10 to 16. In the 60 to 69 class, there were 8. And in the last class, there were 3. Okay, so this is our histogram of test scores. And from this we can get that visual shape of the data. We see it with that slow rise, a peak, and then sort of dropping off quickly here. We only have 50 values. Perhaps if there were more test scores to be included in the sample, we might see this take on a more normal curve. But we can see we do get a feel for the shape of the data from the histogram. So now let's redo this and use the relative frequency information and create a relative frequency histogram. Okay, on a relative frequency histogram, of course our vertical axis now are the percents, or the, I'll just abbreviate, relative frequency. And so our percents here, let's say that's the first bar is 10%, 20%, 30%, 40%. Okay, our classes down here are the same. And now we're going to organize this into our relative frequency histogram. So in the first class we have 4% of the data falling in there. And in the next class it's 8%. The next class is 14%. The next class is 20%. And then 32%. (16%) right in here approximately, and then 6%. So we can see that the data is still taking on that same shape here on our relative frequency distribution. Frequency histogram, sorry, our relative frequency histogram. The height of the bars give us the relative frequency. And in fact, the shape that we get from the relative frequency histogram is the same as the shape we get from the frequency histogram. See if we can put those on top of each other, and they're, I've freehanded this, but they're approximately the same.